Let's explain the Android CertPathValidatorException. Trust anchor for certification path, not found error. This frustrating error pops up when your Android app tries to connect to a server using HTTPS, but the system can't verify the server's security certificate. Think of it like this. Your app needs to show its ID to the server to prove it's legit, and the server does the same. This ID is the security certificate. The problem is that Android can't find the right keys to verify the server's ID. This is precisely what the error message is telling you. Let's break down why this happens and how to fix it. 1. Understanding trust anchors. At the heart of this issue are trust anchors. These are essentially trusted root certificates pre-installed on your Android device. They're like the well-known authorities that verify other certificates. When your app connects to a server, it checks the server's certificate against these trust anchors. If the certificate's chain of trust can be traced back to one of these anchors, the connection is deemed secure. If not, you get that dreaded error. 2. Causes of the error. Several things can trigger this. A common reason is a self-signed certificate on the server. Self-signed certificates are created by the server itself, not by a recognized certificate authority, like Let's Encrypt or DigiCert. Because Android doesn't automatically trust self-signed certificates, it can't validate the server's identity, resulting in the error. Another cause could be an outdated or incorrectly configured server certificate. The certificate might have expired, or the certificate chain might be broken, preventing Android from tracing it back to a trusted root certificate. Network issues like incorrect proxy settings or a corrupted certificate store on the device can also contribute. Finally, it's possible your app is trying to access a server that uses a certificate from a certificate authority that isn't included in the device's pre-installed list of trusted roots. 3. Troubleshooting steps. First, verify the server's certificate. Make sure it's valid, not expired, and issued by a trusted certificate authority. Check the server's configuration to ensure the certificate is correctly installed and configured. If you're dealing with a self-signed certificate for development or testing purposes, you'll need to add it to your Android emulator or device's trust store. This usually involves importing the certificate into the device's system key store, which requires a bit more technical know-how. There are tutorials available online for this, but proceed cautiously as this affects your device's security. For production apps, you absolutely should not use a self-signed certificate. Instead, you'll need a certificate from a trusted certificate authority. Check your network settings to rule out any proxy problems. Lastly, clearing your app's data and reinstalling it might resolve issues caused by a corrupted certificate cache within the app itself. 4. Preventing future issues. Always use certificates from reputable certificate authorities for production environments. For development and testing, use a local network or testing environment that allows for self-signed certificates if you need to. Regularly update your Android device's security patches, as these updates often include updated root certificates. Thoroughly test your app's network connections in various environments before releasing it publicly. The key is proactive verification and testing to ensure seamless and secure connections.